Hi everybody! In this video, we're going to talk about the canonical disjunctive form. So far, we've learned that a Boolean function can be represented in several different ways, such as a truth table or a Boolean expression. The challenge is that a single function can often be written by many different but equivalent Boolean expressions. To avoid this ambiguity, we use a canonical form. The word canonical means standard or following a specific set of rules. When everyone uses the same rules, the same Boolean function will always produce the same expression. To write our Boolean expression into DNF, we start by building a full truth table. Then we'll concentrate on the rows where our expression is true. From those expressions, we're going to write a minterm. That means we'll join the variables, either complemented or not complemented, with the connector of AND. Once we have all the minterms, we connect them with OR. But as always, let's look at some examples so you can see how to do this step by step. We'll start small with P implies Q. In our truth table, we'll need a column for P, one for Q, and then one for P implies Q. P starts 1, 1, 0, 0, and Q starts 1, 0, 1, 0. This is our basic setup. Now let's think back to implies. With implies, we always think about what's false. True implies false is false, everything else is true. So true, true is true. True false is false, false true is true, and then false false is true. Now we want to look for every row where P implies Q is equal to 1. This contributes one midterm to our expression. So we'll have midterms for the first, third, and fourth rows. In the first row, we can see P and Q were both true, so we write P and Q. We're going to skip the second row because it's false. In the third row, we have 0, 1. So the 0 for P means that's not P. So we're going to write not P and Q. Then the 0, 0 in the fourth row means not P and not Q. So there's our expression, not P and not Q. We're going to join all of these minterms together with the connector of OR. This gives us that P implies Q is equivalent to P and Q, or not P and Q, or not P and not Q. Let's look at a bigger statement. This time I have P if and only if Q and R. In my truth table, I'm going to need columns for P, Q, and R. Then I need to know Q and R before I put the whole thing together as P if and only if Q and R. P, Q, and R columns are basic. We do the same thing every time. P starts 4 trues and 4 falses. So 1, 1, 1, 1, 0, 0, 0, 0. Q's going to go true, true, false, false, true, true, false, false. And then R is true, false, true, false, true, false, true, false. We want to put Q and R together. We're using the connective of AND. AND says both things have to be true in order for the connection to be true. We'll start with 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. Then 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. And then 0, 0 is 0. We're going to put that together with our first column P, and we're using the connective of if and only if, which is the biconditional. A biconditional is only true when the two truth values match. So if they're both 1 or if they're both 0. In our first case, we have 1, 1, which is 1. Then we have 1, 0, which is 0. 1, 0 is 0. 1, 0 is 0. Then we have 0, 1 is 0, followed by 0, 0, which is 1. 0, 0 is 1, and then 0, 0 is 1. Now we're ready to select our minterms. We're going to grab the first row and the bottom 3 rows. In the first row, 1, 1, 1 says P and Q and R. Then we skip the next few rows until we get to another minterm. Here I have 0, 1, 0. The zeros we write as complements. So I have not P and Q and not R. Then 0, 0, 1 will be not P, not Q, and R. Then 0, 0, 0 is not P and not Q and not R. We're going to collect all the minterms, connect them together with an OR. Remember, when we do DNF, we're making an OR of ANDs. So we have P if and only if Q and R is equivalent to P and Q and R, or not P and Q and not R, or not P and not Q and R, or not P and not Q and not R. As a wrap-up, when you're doing the canonical DNF, you want to first identify the rows of the truth table where the function has a value of 1. Next, write one AND term for each of those rows by matching the values of the variables. Finally, you'll combine all of those AND terms using OR operations to form the canonical DNF expression.